In this video, we'll take a look at what is a piecewise function. So we can illustrate that with a swimming pool. And if we look at this diagram, we can see that the depth of the pool changes as we move left to right. We start off sloping down, we go to a flat bottom, we slope up a little bit, and then we slope up some more, but at a slightly different rate. So we can transfer this shape onto a coordinate grid and take a look at this as a mathematical function. We're going to call this function d of x, which is the depth of the pool at any value of x. X is going to be our distance from the very left edge of the pool in feet, and y will be the depth of the pool in feet at whatever value of x we're interested in. Now if I look at this, I don't see this looking like any function that I've ever seen before. It's not x squared, it's not e to the x, but I do see that there are four linear segments that make up this graph. And so I can describe each of these segments with a straight line. For example, this first segment is the line -3/4 x minus 6. The next segment is the horizontal line y equals -9. Then I have a line 3/5 x minus 18. And finally, my last segment is part of the line 2/5 x minus 14. Now, none of these describes the pool in its entirety. However, each describes it in a certain piece. And so I'm going to divide the pool up into the four pieces where each line represents the depth of the pool. And so now what I'll do is I'll take a look at the first section from 0 to 4 feet, and I'm going to save just the piece that fits into that part of the pool. Do the same with the second, the third, and the fourth sections of the pool. So now we can assemble these four pieces into a piecewise function. We know that the red section, which goes between 0 and 4 feet, has the formula -3/4 x minus 6, but that's only good for values of x from 0 to 4, including 0. Take a look at the second section. This has a depth of -9 for all values of x between 4 and 15, including x equals 4. In the next section, we have the equation 3/5 x minus 18, but this is only good for values of x, distances of 15 to 20 feet, including 15. And finally, the same thing for the very last section, between 20 and 25 feet, including both of those numbers, we have the equation 2/5 x minus 14. We write the functions as you see on the screen, and then we collect them all together with a curly bracket, and collectively, together, these functions form the function d of x. So this is how we would write a piecewise function, and this is how we might determine the piecewise function from a graph. Let's take a look at d of x in a little bit more detail and try to figure out how we might use this. Now, I like to think about the word if being used between the function formula and what we call the subdomain, or the values of x that each formula is valid for. In other words, d of x is going to be equal to -3/4 x minus 6 if x is between 0 and 4 or equal to 0. d of x is going to be equal to -9 if x is between 4 and 15 or equal to 4, and so on. Now suppose we wanted to figure out d of 7. What this means is we want the depth of the pool 7 feet from the left edge of the pool. This also means that x is equal to 7. So the way that we're going to do this is to look at our if statements first. We're going to test the value x equals 7 against each of these ranges of x to see which function we should use. So is x equal to 7 between 0 and 4 or equal to 0? And of course the answer is no. We're going to move to the next one. Is x between 4 and 15 or equal to 4? And the answer, of course, is yes. And so we're going to use -9 as our function when x is equal to 7. Let's take a look at d of 16. This means our x value is 16. We're looking for the depth of the pool 16 feet from the left edge. So we're going to go ahead and test. Is 16 between 0 and 4? Of course not. Is 16 between 4 and 15? Answer is no. How about 16 between 15 and 20? And again, our answer is yes here. So we'll use the function 3/5 x minus 18, plug in our x value of 16, and we get a value, a depth of the pool of negative 8.4 feet, or 8.4 feet deep. One last thing to keep in mind with piecewise functions, suppose we're looking at d of 32. So the question is, does x equals 32 fit into any of these ranges? And of course the answer is no. This pool's domain, this function's domain, is only from 0 to 25 feet. Values of x between 0 and 25 can give us a depth, but a value of 32 feet is outside of the definition of the pool itself. And so we would say d of 32 is undefined or does not exist. Here's another piecewise function, and what I'd like you to do is to pause the video and see if you can evaluate the three function values below for the values of x that are given. In the first case, where x is negative 10, we see that negative 10 satisfies the condition x is less than negative 4. In other words, negative 10 is less than negative 4. And so we're going to use 2x plus 5, plug in negative 10 for x, and we get negative 15. For the next problem, negative 4 does not fit anywhere. The first subdomain that's on there is x less than negative 4, but that does not include negative 4, and none of the other subdomains include negative 4 either. Therefore, f of negative 4 does not exist. And finally, x is equal to 2. We see that x is equal to 2 satisfies that very last subdomain of x greater than or equal to 2, and so we plug in 2 into that function, and our answer is 2.